Good morning. All right, so first off, I am not a computer scientist. My background's in public policy and communications. My background is in working in the federal government. I've also lived and worked in India, where I helped to run a large public health program. And I did a little bit of work in academia at Harvard, where I got my master's in public policy, and then spent 8 years at the Bill and Melinda Gates Foundation before coming here to Google. So when I came here to Google, I was attracted by maybe something a little different than the normal engineer here. I was attracted to something that I had read that the founders had said in their founding letter, that they had an intention to be a different kind of company. And part of what they meant by that was that they were going to devote significant resources. In fact, 1% of Google's yearly profit, 1% of its equity towards philanthropy or towards innovating for good. And they even said that they hoped and aspired that someday that effort of Google would actually eclipse the impact of the company itself. So that's a pretty audacious goal, and the motivations behind it were very attractive to me. So that's what brought me here. So I work with Google.org, which is the strategic philanthropy part of Google, but philanthropy is woven throughout the fabric here at Google, and there's a lot of different activities going on besides just Google.org itself. In general, what we focus on are the themes here, and these are some of the themes I understand are being highlighted at your conference, working on issues like clean energy, working on using technology to help bring more access to information, making government more accountable, making government more interactive and available to citizens, working specifically around global health issues and poverty issues. How can we use mobile technologies to ensure that we're not only helping businesses improve their efficiency, but to help consumers, to help regular people as well. So Google.org itself, when I first came and we first started, Google said, okay, we're going to take an approach where we're going to try all the keys on the keyboard. That was the phrase. We're going to do some grants to nonprofits, like maybe along the lines of the research grants. We're going to partner with some people and give resources. We're also going to invest in companies, because we believe that sometimes the private sector is really the answer, and that there are entrepreneurs and small companies that we want to back. So we're going to invest. We're also going to use Google's engineers, and we're going to build software and develop projects ourselves. And we're going to do this advocacy thing, which means that we're going to use the name of Google, the brand of Google, the political muscle of Google inside DC and other capitals to push public policies. So we went down that path for a couple of years, and then we sort of pulled back and did a review. And what we learned is that the grants that we gave, we made about $100 million in grants and investments. We looked at that. We were very proud of what we did. We had supported a lot of really good partners. But we realized, we weren't really hitting on what we, Google, could do uniquely. A lot of the grants that we were giving, the things that we were doing, were things that other people could do. So we've really refocused more recently. And Megan Smith has come over. She's our VP of New Business Development. She's an engineer. She's come over to help us to focus even more tightly on what are the engineering projects that we can do. And we're keeping the advocacy focus, because we understand that it's not enough sometimes to have a technology solution. You need to make sure that that solution has the ecosystem, the enabling environment around it, with correct public policies and raising awareness, that sort of thing, to make it work. So that's our focus. Now, as I said, there's doing good and using technology to do good is just part of the normal day for a lot of engineers here. There are so many projects going on at Google that I don't even know about, where engineers, small group of engineers, are looking at their product, looking at their technology, and saying, we're focusing on this for this purpose, but gosh, if we did this or tweaked it this way, I bet we could help in this. And what I love about Google is that there's just a spirit of openness about that, and there's so much encouragement for individuals in their 20% time or in other methods to just follow those paths. So you see a lot of good coming out of that setup as well. So today in my talk, what I'm going to do is just quickly run through at a high level some of the engineering projects that we're working on. And a lot of these projects will have the technical leads coming and speaking later this afternoon and tomorrow. So if you have technical questions, they might be the most appropriate to answer that, but I can give it a try as well. my colleague Christiaan is going to come up and do some demo of Google Earth and how we're using geospatial data, especially data mixed, mixed with other data for impact. And then I'm going to give a sneak preview of a couple of things, sort of confidentially, that we're thinking about doing, haven't been green-lighted. We're not talking about them externally yet, but thought we'd preview them for this audience because there might be potential for partnerships with you all. All right. So, just quickly wanted to add that some of you are associated with nonprofits, and one of the pieces of philanthropy at Google I did want to point out, if you're not aware of it, is this site that helps extend the reach of Google products to nonprofits. For example, our Google Grants program gives over has given over $500 million in free ads to nonprofits, so that's a good thing to be aware of. Okay, so I'm going to start with Google Power Meter. This is a gadget that's available on computers that gives you your real-time energy data. So we have this rolled out now in a few pilots. We've got 9 partnerships with utilities in the US, India, Canada. I think that's it. And Germany. So as you can tell here from this simple screenshot, and the product's actually, I think, improved since we grabbed this. It basically will just show a consumer the spikes around their energy use. And so you can discern the energy use of your dryer compared to, say, your TV and understand relatively how much energy you're using. So why are we interested in doing something like this? Well, research shows that just by making consumers aware of their energy use, they will automatically reduce their energy use by 10%. So that's significant. If half of the households in the United States drop their usage 10%, that's the equivalent of taking 8 million cars off the road. So this is scalable. The other important thing about this is, as I was driving in this morning and listening to NPR, they were saying there's a new study out that even in progressive California, when you ask people what are their top priorities in the environment, climate change and worries about climate change are decreasing. And even in California, we're number 3. We're behind drought and forest fires. So we really believe that it's not enough to just create technology, create tools, create information for people who are self-motivated to do something about the environment. We need to create things that work with hundreds of millions of consumers and give them a self-interest in the action. So something like this, a tool like Power Meter, will not only reduce energy, but it'll also help consumers save money, which is important. So we have a small group of engineers who are working on this. There are a lot of other of these kinds of devices being developed right now. We think that's great. We're just hoping to push innovation across the field. We hope our particular product is successful, but this is an example where, more importantly than our particular product, we really want to see innovation and progress in this field. So this is an example where we have policy partnering with our engineering to further our impact, because having a solution, a device like this, requires a whole infrastructure. So you may have heard about smart grid, smart meters. This is very exciting. We have a window of opportunity right now because in the last stimulus bill passed, the Obama administration put in money, almost $4 billion for this smart grid concept. And so this is going to allow the deployment of more smart meters, and a smart meter is necessary in order for an in-home device like this one or our competitors to work. So we have this wonderful window of opportunity where we have significant funding, and we're putting together the what we call the energy internet, or the smart grid. Now, the interesting thing is I just got a flyer from PG&E at my house the other day, and they said, "Hey, congratulations, we just installed a smart meter." I never would have known, right? The only way I would have known is maybe I didn't see Molly Maid Meter coming by to read my meter. But they mentioned that they never once mentioned in this brochure that, oh, by the way, by having a smart meter in place, if we PG&E were to partner with someone, you could get your real-time energy information. So we need to ensure that the system that's being set up has a consumer focus, that the smart grid that's being deployed and the smart meter partnerships that are being built are built on an open system with shared protocols, open protocols, so that we can have interoperability, and we need to make sure that there's a consumer focus there. And so that's what my team is working on. We're doing that by lobbying on the Hill. We have an energy expert, Dan Riker, who was on the short list for Secretary of Energy. He's on the Hill quite often, speaks quite a bit about this. We do a lot of media interviews because we want to raise awareness around both the potential, but as well as some of the obstacles that are in the path. So that's power meter. So RE less than C. You know, here at Google, we use energy as in the course of business. And we're doing everything we can. We take that energy use, we take our carbon footprint very seriously. So we're doing everything we can to build the most efficient data centers. We think we do have the most efficient data centers in the world. Bill Weil, who's going to speak here later, will be available to talk about what we're doing there. We're sharing best practices as well on our data centers. But we still use a significant amount of energy. And the fact of the matter is, Google uses the same energy mix as the rest of America, and we don't like our options. We don't like the fact that there isn't utility scale renewable energy available that's cost competitive with coal. We want that. We know others want that. Same point about power meter. When you do something that's going to work in the marketplace, that'll work with consumers, you don't have to worry about people paying a premium for renewable energy. We want renewable energy available that's cheaper than coal, thus RE less than C. So as we examined this area and looked at what we, Google, could do in sort of a unique way, a couple of things came up. Our engineers said that there were 3 technologies that we think have the most promise to reach the renewable energy cheaper than coal threshold. So for us, it's concentrated solar thermal, enhanced geothermal systems, and high altitude wind. So to promote these technologies, we've taken a 3-prong approach. One, we've invested in companies. So we invested $45 million in new companies in solar thermal. BrightSource, you might have heard of them, eSolar, on EGS, Potter Drilling, that's looking at new drills that can get the bits down, and in high altitude wind, a local company, Makani Power. So we made these investments in small startups and companies that we felt were on the right path, but needed more money. But this was an area where Larry Page in particular was very involved and said, you know, it's not enough to just fund others and other ideas that are out there. We really think that this is something that Google might be able to do with engineers. Who knew? Who knew? So we actually now have a small team of engineers in-house who are working on renewable energy. So they're looking particularly around these types of energy for ways that we could help design better, create software that would fill some of the strategic gaps. And we're not talking too much right now about the specific areas we're looking at. Probably in the next quarter or so, we'll come out a little bit more about that. Not exactly sure right now, you know, does this mean that Google's going to actually, you know, build power plants and deploy this kind of renewable energy? You know, maybe, or maybe we're going to do a shared licensing approach, or, you know, who knows. But this is a case where we wanted to do some of that engineering, look at what we could do in-house as well. So, you know, I'm optimistic that our group of engineers is going to make some progress and share results. But the fact of the matter is, it just can't be Google, and it just can't be a few guys down the street, and it just can't be, you know, Bill Wilson, what he's doing. We need hundreds of thousands of people around the world globally working on RE less than C. So that's where policy comes in. You know, candidate Obama talked about a renewable energy fund of $150 billion over 10 years. And we know that candidates always tend to talk a little bit bigger, and then you come down to reality, and we've had this minor global meltdown and stimulus bill that's taken a lot of funding. But we believe, actually, that's the order of funding that we're going to need, and not only, but smart funding to the correct technologies backing good players who are incentivized to share information and results and data to get to where we need to be. Now, so the good news is that the stimulus did contain about $2.5 billion in new funding for R&D, and that's significant, but it's not near where we need to be. And more importantly, what we're looking at from the policy angle is that you just can't have these years where you have a flood of money and then you have a trough, and there's just no stability, there's no ability to predict stable funding flows. So we're working with a lot of others in coalition to lobby for stable funding for incentives, for mandates, if that makes sense. We're looking at things like renewable portfolio standards at the utility level that require certain amounts of renewable electricity mix in utilities. We're also looking at issues, gating issues like transmission. As an example where Google might be helpful on something like the transmission issue is by we've built earth layers where we show ecologically sensitive areas where it would not be good to run transmission lines. And we've looked at promising areas for renewable energy, whether it's solar thermal or EGS or PV, and built these maps and layers to help people to design siting that makes sense, both from wildlife and from a renewable energy perspective. Again, in the energy area, our Recharge It program, we started this a couple years ago, really felt that plug-in electric hybrid cars were not getting the attention that they deserved. It was sort of seen like this idea that was many years out. Now, you're all nodding, well, yeah, of course, we know about this. It seems plausible. Yeah, Honda's going to come out with one. A couple years ago, that wasn't so sure. So we thought, okay, this is a place where we might be able to have a catalytic impact. And one area where we could do that is we noticed that, there's a lot of people out there, activists promoting plugins, talking about, my car got 100 miles per gallon, that sort of thing. But we hadn't really seen good data available comparing what a plug-in might receive versus other cars. So we purchased 8 Toyota Priuses. We converted them ourselves with a high motion kit. So we have these plug-in cars. They're branded Recharge It. You might see them plugged in under our solar carports. We make these available to Googlers. So if Googlers use our shuttles or our self-powered commuters, they can take these cars out during the day if they need to run errands. But we also ran a driving experiment where we compared real-life driving with professional drivers on several different courses to say, what are you going to get? So we got 93 miles per gallon on our plugins, and these are not optimized, right? These are just conversion kits. So these are not even the best of what plug-in cars could get. And then we compared that to a regular Prius, which was about 43. Toyota Corolla was about 30. Ford Expedition was about 14. So even just publicizing that sort of data, just very basic data, was helpful to inform the discussion. We have Larry, Sergey, and Eric, who all care very passionately about these issues, who incorporate these kind of facts in their speeches, and that really helped garner some attention. We have just a small group of engineers looking at smart charging and demand response to see what might be possible. And our cars, our 8, are now receiving a signal from the grid operator on when to charge and how much. So this is a look at what might be done in the future with plugins. So I'm going to switch gears now and talk about something we're doing on the health side. How many of you have ever heard of flu trends or played around with flu trends? Yeah, a few of you. It became a lot more popular, swine flu. So the idea with flu trends is that our engineers discovered that a lot of people use Google to search for more health information, and that we can correlate aggregated search queries with truth data, like data from the CDC on actual flu incidents, and we can build models that helped predict and even detect real-time or within a day flu activity. So we built a model for the US that we launched, and the information is available at a state level as well. And what we found is that our daily publication, our daily updates on flu tracked very closely. Our correlation was above 0.9 with CDC data. Now, CDC, Center for Disease Control, they collect their data by, you're feeling sick, maybe you go to the doctor, you present with flu-like illness, they'll record that. If you're really sick, they'll take a culture and run it, and that takes several days, and then they'll get those results back. They take all of that data, they send it off to a centralized bureaucracy that then gathers all of that and publishes it. Well, that usually takes about a week or two. But what we found is our data, which was highly correlated with theirs, is available daily, or even sooner when necessary. So Jeremy Ginsburg, who led the engineering team, did a great job with that. We published it. We were very happy about that. We were looking at potentially Europe, maybe Australia for the Southern Hemisphere flu epidemic. And then we get a call from Mexican health officials and the CDC saying, so what are you seeing in Mexico? And we're like, well, actually, we don't have a system built for Mexico. We're not seeing anything. Really, how long would it take you to build a system for Mexico? Huh. So our engineering team very quickly, using the same sort of system, put together a model for Mexico. Now, the problem with Mexico is that we don't have the truth data the way that we have in the US with the CDC, the very reliable 10 years of historical flu data. So they were a little unsure of the model because of that. And then also, as word starts trickling out, you start to see variation between what are people just searching because they've heard about flu or because they're actually experiencing illness. But what we did see is that we were able to detect before widespread news coverage had picked it up, when it was still just a bit of a buzz in the health community, and an unusual uptick in flu activity in Mexico outside the standard sort of flu season. So we told the health officials, look, this is very provisional. We don't know. It's not robust. We haven't validated it. But let us share it with you real time, just to kind of help. And this was really helpful in the early days because they didn't know the denominator. They knew a lot of people were becoming sick and dying, but they didn't know how virulent it was because they didn't really have a good baseline or a good feeling for how many people were experiencing flu. So we're continuing to work on our model. We'll be launching internationally in other countries as well. But this is an example, when I said earlier on, where we were trying to figure out, well, what can we do and what can we contribute that's unique to Google? I think this is a good example. So I'm going to pause for just a minute and shift gears and invite my colleague Christiaan to come up and give a demo of Google Earth to demonstrate how it's being used today for impact. And then I'll very quickly give a preview of a couple new ideas that we have in the hopper that we might be doing.
My name is Christiaan Adams. I work with Google.org as well as with the Google Earth Outreach team. I'm a GIS and mapping specialist to help nonprofits and all sorts of organizations to use Google Earth and Google Maps and display their data in our online mapping tools. So, real quick tour here. The first thing that most people do when they fire up Google Earth. Actually, let me ask first. Who's actually used Google Earth? Probably most people in the room. Who's actually created a layer for Google Earth, like put some data on there to visualize? Okay, a bunch of you. Great. Hopefully you can see that there's some really cool ways you can visualize data here and see if there's something that you might want to visualize in your own work. So the first thing most people do is fly into their home, and we'll go check out the Googleplex real quick. You can see it's all 3 dimensions in Google Earth. We have our 3D buildings there. We have to fly into San Francisco while we're here as well, because this is just too cool. But let's get on to some examples of how this is used for public benefit. One of the most, the better known examples that you may have seen before is the Crisis in Darfur layer that was created by the U.S. Holocaust Memorial Museum. This was actually updated this week with the latest data of villages that have been destroyed or damaged in the Darfur region of Sudan. And it's a pretty incredible layer. It shows how when you put data in context and show it with all the background data that we have, our imagery and other data, it really brings your cause or your message to life. This is a village that you can see is burned to the ground in Darfur, and there are thousands of them. And this layer was one of several things that helped bring attention to this issue. You can see these are just a collection of points, pretty easy to create, and you can put all sorts of information in here, including for these organizations, it's very important to have links back to their website to get people to see their other content and take action or do what they want them to do on their website. Let's show an example of another kind of information you could put on here with when you have time-based information. This is actually an example of the previous flu epidemic that made international news, the bird flu. And I can play this with our time slider here. We can see it 2004. The circles are animal cases, the triangles are human cases. You can see it spreading into Europe. Continue playing through there. Spreading across Central Asia into Europe and West Africa. So again, a cool visualization of some data that was put together by, in this case, Jacquelline Butler. He put this all together, and each one of those points has some info about the case and where the data came from. This layer, as Jacqueline mentioned, we're working to promote enhanced geothermal energy, and we created a data layer ourselves at google.org that shows the enhanced geothermal, or EGS as we like to call it, potential across the US. Now here's what we call an image overlay. This is the temperature at 7.5 kilometers down. Takes about 150 to 200 degrees Celsius minimum to have efficient heat extraction for energy production. We have layers at different depths here. I don't have time to go through them all. Here's 4.5 kilometers, not quite as hot, but you can still see the hot spot at Yellowstone up here. And then we can put place marks in each state where we had state-by-state data on the resources in that state compared to their current generating capacity. It's pretty impressive numbers there. These are charts produced by our chart API. And we can also do some cool 3D visualization of this with whatever parameters you want. In this case, it's the geothermal resource in that state. And wanted to show off a couple of the neat things that we've done more recently with Google Earth. Earlier this year, we launched Ocean in Google Earth, and you can see we have some very high resolution bathymetry data in Monterey Bay. If we wait for a second, hopefully the waves will start moving. There we go. We can see the ocean surface here, and we can dive underneath and actually explore the bathymetry. Let me fly back out here for a moment and encourage you to check out in the layers panel here. These are all the built-in layers that we have in Google Earth. The global awareness layers are things that we work on with the Earth Outreach team. These are organizations who've created really interesting content for environmental and humanitarian and other things like that. And there's also the ocean layer. Turn that one on. Lots of things under there you can explore.
L'outre, avec tes moustaches argentées et hérissées.
So very easy to embed a YouTube video in Google Earth balloons, just HTML content in each of those balloons. Hopefully, you all being computer science experts can develop more cool ways of developing content for Google Earth. And what was the last thing I wanted to show here? Yes. The other neat new feature in Google Earth. I'm going to start by flying in here to a little place called Cape Canaveral. And then I'm going to switch over to Moon. Give it a second. This is the launch pad for the Apollo program, or one of the launch pads for the Apollo program. Give this a moment. Come on. So I'll say we have the oceans are built right into Google Earth. We now have underwater bathymetry and underwater terrain. We also have Mars in Google Earth. You can go and explore Mars because we have a lot of great data there. We have sky, so you can look out, put all your star and sky data in. And if Moon will come up, I may just have to skip that one because Yeah, probably. Haven't had this problem before, but yeah, we're all subject to bugs, I guess. So, yeah, Jacqueline, I'll give it back to you. Oh, wait. There we go. I threatened it with not showing, and here it comes. There we go. We can go and explore all sorts of cool stuff in here, like all the human artifacts, all the spacecraft and other things that are scattered all over the moon. And where is it? Our historical maps. And turn on these geological charts that were used for planning some of the Apollo missions. They're pretty amazing to look at. This is essentially what they used to plan the Apollo missions. These charts in the USGS. We can also go in and fly into the individual Apollo mission landing sites. This is the last one at Apollo 17. Actually, let me fly to Apollo 11, which is the first one. And we can see these maps, and you can see the lander there. And I think we have a YouTube video once again.
One small step for man, one giant leap for mankind.
So lots of things to explore in there. We're using this with a lot of organizations to do some really great advocacy and promotion work for nonprofits, and hopefully you can use the power of what you do to create some really awesome visualizations as well.
Awesome. Can you turn it back open? So I'm just going to highlight a couple areas that we're thinking about working. So these aren't things that are green lighted, areas we're thinking about working on. So obviously one thing that we're thinking about is how can Google be helpful in disaster response, hurricanes, cyclones, that sort of thing. And in the past, what we've done, such as when Cyclone Nargis hit Myanmar and killed, as you remember, about 140,000 people, immediately make available imagery and data that helps. The red here is the hardest hit zones. But you also, see in a crisis response situation that speed is very important. Getting all the information available in one central place is important. Groups like the Red Cross want to be able to get up and say, look, we have shelter here, or here are the roads that are down, or here are bridges that are up, here are hospitals. People on the ground want to upload videos. We want to have access to all sorts of different information feeds and types. We want news, we want blogs, we want sourced data, like from EpiNet, but we also want crowdsourcing. We want information from crowds. So this is an area that Google's exploring to see how might we be helpful in creating this kind of a platform where we have both the imagery as well as the associated data and communication tools. Another area we're looking at is in Christiaan's world, and his team's really looking at this, which is how can we use some of the remote sensing data that has very rich data associated with each pixel, and how can we look at changes over time, monitoring those changes over time to detect things like deforestation. So this simple photo shows in Google Earth using the historical function, you can look back at 1975 at this area in the Brazilian rainforest, and then you can look 25 years later and see what's happened to it. So this is just, one example. Imagine if you could do this with huge data sources, run algorithms against it, hosted in the cloud. The reason why this is important for something like deforestation is that, we're coming up on the post-Kyoto global negotiations in Copenhagen, and there's a real effort afoot to make forests worth more whole than dead. Right now there's just the perverse incentives that people can go in and do logging and make money, but there's no market now that captures all the positive externalities associated with the rainforest. Not only in its link to climate change, we estimate that deforestation is responsible for about 20% of human-caused emissions, but the Amazon is also the lungs of the world, provides 20% of the oxygen, biodiversity, the livelihoods associated. So how do you create a marketplace? Well, you can if you can effectively automate the monitoring of deforestation, and then provide incentives for local groups to keep forests whole. So this is another area that we're looking at. So with that, we'll wrap up, but I think we might have just a couple minutes to take any questions. Thank you. Any questions for Christiaan or myself? Yeah.
So do you have any method of validating all this data before you put it on? Like, how do you know that this is...
Nah, we don't.
You mean in Google Earth?
Google Earth, yeah.
Okay. So we provide some data here. Let me switch back to Earth. And, the data in the layers panel are things, you start with imagery. So that's satellite imagery that we buy from commercial companies. We have things like roads and borders and those things. And we have a team of people that check pretty carefully that that's high quality data, some of it we buy from other sources. But a lot of the data in Google Earth is, we want to encourage everybody to create data and put their own layers on our tools, and that it's just like a web page. You have to do your own due diligence and see who created it, who created that layer. You don't need our approval to visualize your data on Google Earth.
But the layers that you highlight in the awareness here are more curated and
so right. For example, the layers in the global awareness folder here, these are all from reputable organizations that we've worked with, but they're all still labeled from those organizations, so it's their data.
Mechanism like Wikipedia has to validate the information.
Like Wikipedia?
Yeah.
Not for these layers. Some of the individual layers do have that kind of thing. Like we have a YouTube layer in here, and we actually have a Wikipedia layer if you open up the geographic web, and that uses some of that user-generated confirmation of the quality of the data. So
it's interesting because there's a dynamic right between validating and speed. So we saw with H1N1, people were doing the same thing that Declan Butler, who's a reporter at Nature, had done in publishing these layers very quickly. And there soon emerged this sort of global spat about the validity of some of the data. And so then you did see this sort of Wikipedia crowd editing, sourcing, working with one another to validate. And then they did create sort of these hybrid models where, you have to know someone to get in to update it, and yet still semi-open to balance the speed. On the validation point, I wanted to point out with flu trends that the U.S. data was validated against 5 years of historical data. It was just with Mexico, in the interest of time and because we didn't have the truth data, that we went ahead and published with lots of caveats to say this may be helpful, but it's not validated. Anything else? Yeah?
So I was interested that some of the projects that you've undertaken really seem to play to Google's strengths, like the flu trends, the ability to gather tremendous amounts of data and analyze it. And others just seem to sort of reflect an interest that's not a priori tied to Google, like hybrid cars or green energy generation. Is there how do you decide which of the many good works fit within your portfolio? And just to throw out one that I didn't hear about, given Google's ability to move information and such, has there been any thought to contributing to the dissemination of information to, in regimes where such dissemination is limited, the way we saw sort of Twitter being used in Iran recently? That just as an example of one that really does seem to play to your strengths, but that I didn't see discussed.
Yeah. So that's a really good question. I mean, the truth is that we focus mostly, we have a series of filters that we use, right, as we consider what we could do. So one of the filters, is it a big, bad enough problem? Is it going to affect not tens of hundreds of, but millions of people? Is there a unique role for Google? Is there something that we can do where we have a real comparative advantage? Is it something that our engineering teams themselves could do that or build on existing systems? Is it something scalable and platform? We don't really do a lot of one-off proprietary stuff. We want to build platforms that enable others to do it. So we have a series of filters like that help us get to it. As far as energy, I think it's both because we are a large and growing user of energy ourselves, and that our founders as well as our CEO care passionately and believe deeply in climate change, and that we want to be a part of the solution and not part of the problem. So that sort of drives our unique perspective there. You know, as far as how can our tools be used to help dissidents, to help access to information in repressive countries, this is something that is very, very close to the heart of Google. We take content and free expression very seriously. We have a lot of teams at Google. I don't know if Christiaan is still here, but we have teams outside of .org that are looking at government accountability and sharing of information. In the Iran example that you just mentioned, you know, YouTube was very helpful in terms of getting the smuggled tapes out and published right away and then made available to the world.
Just one thing on our end. We also launched Farsi and Persian that same week.
No, in like how many days?
About a week after when we were thinking about it, but we hadn't felt the quality was quite as good as our other translations because there's a dearth of parallel text between the Persian language or Farsi and English. So we had trouble perfecting it, but we got it out anyway because of exactly what you were thinking.
Yeah. Sorry. So I think we're out of time. Maybe we should just take one more question before we let you eat, or maybe we'll just let you eat. All right, we vote for let you eat. Okay, thank you.